So this is our second day on the worksheet. Who wants to read for us number 2 now? Dana, go ahead.
Two ship or shooters leave home traveling in opposite directions. Catwoman is walking and Batman is biking, averaging 6 kilometers per hour more than Catwoman. If they are 18 kilometers apart after 1.5 hours, what is the rate of speed?
There you go. So now I want you to then think about this problem as we read this. Is this opposite direction, same direction, or round trip? Raise your hand. Samara, what do you think? Opposite direction. How many agree with her? Good. Now there are 2 types of opposite direction, where they leave from the same place. The other one is where they leave from different. They go towards each other, remember? Which one is it? How about Chuck?
It's from the same spot.
Same spot, exactly right. So it'll look something like this, isn't that right? So because they told us that they're leaving from their house and then they're going opposite direction. And so this is good, right? To know what sort of pictures we need, right? Here's the motion picture. What are the unknowns for this? Yes, Carolyn?
The speed Catwoman is going.
Yeah, the speed that Catwoman is going, but at the end it says what is the speed rate of each, and we need the speed of Catwoman and the speed of the Batman. Does that make sense? Don't we already know how fast Batman is going? It looks like it's going 6 kilometers per hour.
No.
No, that's how you get it wrong. Why is that not the case? Yes, Samuel? More than Catwoman. So whatever the Catwoman is, you add 6 kilometers an hour to that. Does that make sense? So can you all declare your variable? Which one should we declare our variable for? The rate of the Catwoman or the Batman?
Catwoman.
Yeah, I will do Catwoman, right? Because isn't that smaller amount? We want to declare a variable for the smaller amount because I like addition better. Right. Go ahead, everybody try. I'll wait. Let's do that and then fill in the chart, okay? So here we go. Spencer, can you tell me what you did for your variable? How did you declare your variable? Let
R equals Catwoman's rate.
Good. I did C. Is that okay? Yeah. Let C be the rate of the Catwoman. I'm sorry. Then what? Yes, Tajwar?
So then C plus 6 equals rate for Batman.
Yeah, there you go. Is that easy, guys? Isn't that what it says? The rate in which the Batman was going is 6 kilometers faster than Catwoman, right? Remember, more than you got to switch the order around. So you get C plus 6 for the rate of the Batman. Yes? Can we fill in the chart?
Yeah.
Go ahead, everybody fill in the chart. Alright, so here's part of it. So who could tell me, by the way, what kind of unit is rate in? Kilometer per hour. Does this say kilometer per minute?
No.
No, so you have to use everything in terms of kilometers and hours. Okay, so the rate determines which units you use. Who could tell me the rates for Cat and Batman? How about Lindsay?
The rate for Catman is C.
Uh-huh.
Batman
Yeah.
is C plus 6.
C plus 6 is correct. Yeah, Catwoman. Yeah. It's not Catman. Okay, and then what about time? How about, who could tell me what to plug in for time? How about Carolyn?
1.5 hours.
1.5 hour for which one? For both is correct.
I didn't know.
You guys are correct. Well, okay, can somebody explain why it is 1.5 for both? Well, Brandon?
Because they both distance went.
Yeah, they both traveled for 1.5 hours, didn't they? Because they started the home, right? And then from there, they both, one of them went, right? They both went opposite direction for 1.5 hours. Now, does this mean that they both travel the same distance? Why not, Matthew? Why wouldn't they have traveled the same distance? Yeah, Batman's faster, right? He's on a bike, isn't he? So therefore, if you go faster for the same amount of time, don't you go more distance? Does that make sense? So you're right, but nevertheless, right? Didn't both of them travel the same amount of time? Right? They start at the same time, they end at the same time. So then what's the distance for Catwoman? Michael? Yeah. Looking at the chart, we know that rate times time equals distance, right? So what is the distance for Catwoman?
I put it into a fraction, trying to save that fraction.
That's fine.
I put 1/2 r.
Sorry?
1/2 r.
Yeah. 1.5 c. Is that right? I use c. You just basically multiply the rate and time. What is the distance for Batman? How about Eric?
Me?
Yeah.
It'd be c plus 6, 1.5 times c plus 6.
That's right. Okay, so now, Joseph, we have to come up with an equation, right? So look at the motion picture that we drew. They're going opposite direction, starting at home, same place. What do you think the equation will be? So do you think the distance that Catwoman traveled is equal to the distance that Batman traveled? Is that what it says from the picture? Not quite. Joseph, look at what it says in the problem. Look at the, can you read the third sentence? If they...
If they are 18 kilometers apart after 1.5 hours.
Good.
What is the rate of
There you go. So after 1.5 hours, how far are they apart? 18. Now, can you represent that 18 kilometers using these distances that we have? How would you do that? So since they're going opposite direction, right? Joseph, look what's happening. One of them going left, one of them going right. What is the distance of Catwoman travel, which would be maybe on the left? And what is the distance that Batman travel, which is maybe on the right? The whole distance is, they said 18, right? So how would you write that as an equation? How would you get 18 kilometers? You add them together, exactly. If you were to add how far Catwoman went, maybe to the left, right? And if you were to add how far Batwoman went, to the right, you add them together, it should be 18, right? So what's the equation? 1.5c plus 18? 18 is how far they were apart. That's the total distance. So it should be 1.5c plus, that's how far Catwoman went, plus how far the Batman went. Isn't that the formula? So tell me again, what's the equation going to be?
1.5c plus 1.5cc plus 6.
Equals to 18. Isn't that how we get it, guys? Right? Look, the distance that Batman went plus the distance that Catwoman went should be 18, right? So you add them together. You add these distances together. Do you see why this picture is important right here? Okay. Now, by the way, I didn't use 1.5. Guess what I used?
1.5.
I could use 1.5, but even better, which is
15.
15. Why is 1.5 15?
Because like.
Oh, okay. No, you can't just write 1.5 as 15. Yeah, Libby? 3/2 is correct. Why do you think I did that? It's easier to simplify, isn't it? Okay, so hold on. First of all, do you get this equation? If I were to add the distance that Catwoman traveled plus the distance that Batman traveled is equal to 18. Correct? Any questions? Yes.
Isn't it supposed to be c plus 9, not 6?
Where did you get 9 from?
That's after you. Yeah, it's after. It's after you.
Yeah. Okay, go ahead and solve then. Are there any questions about this equation? Go ahead, solve. I'll give you time. Of course, help each other out. That's fine. Joseph, do you understand? No? This is okay. Good. By the way, could I have left this as 1.5 if I wanted to? Yeah, it doesn't matter. It's just it's easier for me. Somebody tell me what I get. First, I get 3.5c plus. Yeah. How about Kali?
I got 1.5r plus 9 plus 1.5y equals 18.
If you left it as 3/2, what would you get? 3/2c plus 3/2c plus 9. Isn't that what you get? Because, right, 3/2 times c, isn't that 9, guys? All right, then what's 3 over 2c plus 3 over 2c? 6 over 2, which is 3 plus 9. Subtract 9 from both sides. How many people got c equals to 3? Raise your hand. You could have left it as 1.5. That's fine. 3 over 2 is the same as 1.5. Okay, so if you got c equals to 3, am I done with this question? Raise your hand. Oh, no. Okay. So then, Chris, what do I need to write? They want rate for what? Both of them. What does c equals to 3 represent? Rate for rate for Catwoman, correct? So how do I get the rate for the Batman, Chris? S6. How'd you know to do that? Yeah, they told us. This is 6 more. So here you go. The rate for Catwoman was 3 kilometers an hour. Do you think the unit is important here? Yeah. Okay. And then the rate for Batman is 9 kilometers an hour because it says the rate for Batman was 6 kilometers faster than Catwoman. So there you go. Does this make sense? Do you see how we could come up with an equation? Okay. All right. Now, are there any questions? If no questions, then can I go to example 4, the last one? Yes? All right. Let's go to example 4 then. Who wants to read for us number 4? How about Angel? Go ahead.
Mark drove his car to a haunted house at 4.8 kilometers an hour. When his car disappeared, he had to walk home at a rate of 0.8 kilometers an hour. The drive took 10 minutes less than the walk home. How far did Mark walk for and for how long?
Thank you. Now, who thinks they know what type of question this is? Is this same direction, opposite direction, or round trip? Raise your hand. How about Patty? What do you think? Do you think it's round trip? How many people agree with Patty? You guys are correct. This is a round trip, right? Mark drives to the haunted house, right? And of course, the car, not of course, but then car disappears. And then he has to walk back the same distance, right? And remember what I talked about round trip? They go to the same distance. So distance is going to be what? Same going there and coming back. Does that make sense? They don't take any shortcuts. Okay, unless they say anything like that, okay? So, what are the unknowns for this one here? This one's kind of interesting. At the end it says, Tajwar?
The unknown is how far did the distance that Mark walked and the time that it took him.
Yeah, so that's right. So they're asking for both of these. How far did Mark walk and the time it took him to walk, right? So, which one then should we declare a variable for?
Rate and time.
Not for both, I don't think.
Distance. Oh, no, there's.
Because if you know one, you could find the other. Samuel? Yeah, if you could find his walking time, you could find the distance. How do you find the distance? All you have to do is, yeah? Rate times time. Does that make sense? So this one is kind of interesting. They ask both, but it turns out, really, if you know the rate, if you know the time that Mark walked, you can find the distance easily. All you have to do is multiply that time times, they even tell you how fast he walked, right? 8 kilometers an hour, right? So you just have to multiply. Yeah.
Wait, is it 48 kilometers an hour?
Oh.
Oh, because it looks like 4.8.
Yeah, so that's why I've changed the font. It looks like 4.8, doesn't it, on here? So yeah, it's 48 kilometers an hour and 8 kilometers an hour. But do you understand what I want to declare a variable for? I want to declare the variable for how long it took him to walk. What's the other unknown? How long it took him to drive. So which one has smaller rate, smaller amount? Is it the rate? Is it the time for him to walk, or is it time for him to drive? It's the time for him to drive. So guess what? Do you think it's a good idea to declare the variable for the time he? The smaller. Which one is smaller? The time it took him to drive. That's what I'm going to do. Now, does it matter if you do it the other way? No. So here's the picture. He's driving, and so let t be time it took him to what? Which one should we declare a variable for? Drive. Because that's the shorter. That's a smaller amount, correct? Because if I do this, then could we figure out, or could we write down the other unknown using t? What is then the rate for him to? What is the time for him to? Time it took him to walk.
10 minus 10.
Okay, I want you to all discuss right now with your group. Think about it. Then how are you going to represent time it took him to walk? Go ahead. I'll wait. Hey, you guys want a hint?
Yes.
The hint is it's kilometer per what? Hour. What sort of units do you have to have everything in? Okay, go ahead. Everybody try this. Aaron, what do you think? So if I let T be the time it took him to drive, we don't know how long it took him to walk, right? What did you write? How would you represent that? Aaron, can you read the third sentence? No, it's the second sentence. Yeah, third sentence from the. T minus 10? T plus 10, because it's going to take. How many people wrote down T plus 10? Raise your hand. Okay, that's how you get it wrong. Okay. Raise your hand. Hold on. Guys, hold on. May I have your attention? Thank you. Aaron, this is in kilometer per hour. If you write T plus 10, guess what 10 will represent? So 10 hours, wouldn't it? So how would you represent 10 minutes in terms of hour? What would 10 minutes in hour be? How much of an hour is 10 minutes? Okay, I want you to talk with your group. See if you can figure this out. Go ahead, everybody try. Aaron, were you able to figure this out with your group? What did you write? 10? T what? So how do you represent the time it took him to walk? 1/6? Oh, you just write 1/6? Is that the time? Not quite. It says the drive took 10 minutes less than walk home. So does it mean it only took 10 minutes? Okay, so it says if the drive took 10 minutes less than how long it took him to walk home. How long did it take him to walk home? Look at this here. Aaron? How long did it take him to walk home? Look at what we have up here, Aaron. It took him how long to walk home? Look at what it says up here. What does T represent? T plus 1/6 is correct. Does this make sense? How many people wrote this down? Raise your hand. Okay, did anybody declare the variable for T for time it took to walk?
Yeah, I did that.
Okay, if you did that, then what would you have to do? T minus 1/6. But do I like addition or subtraction? But you could have done that. It doesn't really matter, right? Yeah, this is what we just discussed, right? Did anybody put down T plus 10? What would that mean?
T plus 10 hours.
That'll be 10 hours. Okay, that's not what, right? Any questions? Ask me now. Okay. Discuss with your group. Go ahead. I'll wait. Go ahead. People still confused. Go ahead. Wait. So any question as to why is T plus 1/6? Carolyn, you had that question. Why is it T plus 1/6, not T minus 1/6 in this case?
Because this is drive to 10 minutes less, which means the walking.
Exactly. Which means walking took 10 minutes more than how long it took him to drive, correct? So if you gotta do that carefully, right? Imagine if you put that as T minus 1/6, that would be wrong. Or T minus 10, that would be really wrong. Okay, that'd be 10 hours. All right, so can you then fill in the charts here? Who could tell me the rate for car? Yes, Matthew?
For a drive is 48.
Mm-hmm.
And walk is 8.
There you go, 48 and 8, right? Although on your worksheet, it looks like 4.8, doesn't it? It's 48, okay. All right, for time, what's the time for car? Aaron? How t? What's the time for how much it walked? He walked. T plus 1/6. Very good. It makes sense, doesn't it? It takes them longer too, right? Aren't they going the same distance? Because they're going there and coming back, right? Then what is the distance here, Dana? What's the distance for the car?
48.
That's right. What is the distance for walk, Bella?
8 parentheses, 1/6 plus
Say it again.
t. 8 in parentheses, t plus 1/6.
Exactly, 8 times, right? In parentheses, t plus 1/6. I like how you put parentheses there. Okay, now here comes the part where people seem to sort of get confused. But if you think about this, what do you know about round trip? The distance they're going to the place is same as distance coming back. Now knowing this, and we're looking at the distance column of this chart now. Michael, can you give me the equation? Since it's a round trip, what's the equation?
48t equals to 8 parentheses t plus 6.
Exactly.
Oh.
Isn't this the whoops, where is it? Here's the equation, right? Isn't that the equation? The distance going there with the car is same as distance coming back, even if you're walking or taking a bike, whatever. It doesn't matter. The distance is same. That's why you get an equation, 48t equals to 8 times, in parentheses, t plus 1/6. Any question? Do you guys get how we get this equation? Guys, do you think it's important to understand whether or not it's round trip, opposite direction, same direction?
Yes.
Yeah, that's where it's going to give you the equation, okay? Go ahead, everybody solve, I'll wait. Of course, you can help each other out. All right, Kali, tell me what to write then. What do I do next? How do I solve for t?
Okay. I put 48 t equals 8t plus 1/3.
Yeah, 4/3 or 8/6. Same thing. It's best to simplify first, right? And then, of course, you're right. So I should have written this as 4/3. Okay, because 8/6, you could divide top and bottom by 2, right? And of course, what do I do next then, Brandon? Yeah, subtract 8t from both sides. And I get 40t equals to 8/6 or 4/3. I wrote 4/3 here. Here. There you go. All right, then how do I get t by itself? Divide both sides by 40, correct? Now, what is that same as? Dividing both sides by 40 is same as multiplying both sides by 1/40. That's what I did here. Okay, isn't that same? Hey, does 4 go into 40? Yeah, how many times? Samara, what do I get? Then t, and then of course 40 goes into 40 once, right? So t equals to what? The 4 goes into 40 10 times. 1/30. Okay, I wrote down 1/30 hour. Isn't this in hours? No? Okay. What is 1/30th hour in terms of minutes? 2 minutes, because you can multiply top and bottom by 2, right? So you get 2/60. Isn't that right? How many people got 1/30 hour or 2 minutes? Very good. If you didn't, go ahead and fix it. Do you see your mistake if you didn't get that? I saw some people doing, instead of doing 4/3 divided by 40, they wrote 40 divided by 4/3. Do you get the same answer if you do it that way? No. Is division commutative? Of course not. Okay, so you have to divide both sides by 40, not 40 divided by 4/3. Then you get the wrong answer. Okay, is that what you guys, some of you did? Okay, you can't do that. Class. Just because the number is bigger doesn't mean you always have that number first when you divide. That's wrong. Here, we're dividing both sides by 40, okay? You're not doing the other way around. You're not doing 40 divided by 4/3. You're doing 4/3 divided by 40, right? That's why I like to keep everything as a multiplication, because multiplication, it doesn't matter which order you multiply, right? Any questions so far? Yes, sir. Okay, we'll get there in a minute. Very good. So Samuel understands that, wait, that's not the answer that they're looking for. That's part of it. By the way, is this the answer that they want actually? It says, how far did he walk? And how long? So let's answer the question, how long first, right? Because if you could answer that question, you could figure out the... So how long did he walk then? This is how... What does T represent? T represents how long he drove. So how do I figure out how long he walked? Do you guys see what I'm trying to say?
Yeah.
All right. Hold on. How about Eunice? This is a time. This T represents how long he drove, right? So how do I know how long he walked? Do I do t plus 10? 1 over 6. Now, if I know this is 2 minutes, then you could add that to 10 minutes, right? But, so there are two ways to think of it. He walked, you do, oh, how long here? Here is how long he walked, right? If you know that it was 10 minutes, then you could add, right, 2 plus 10, which is 12 minutes. Now, what if you kept everything in terms of hours? It would be 1 over 30 plus 1/6, right? By the way, 1/6, don't you have to get a common denominator? How do you get a common denominator of 30? Multiply top and bottom of 1/6 by 5, so you get 5 over 30 plus 1 over 30, which is 6 over 30, which is 1/5 of an hour. So you could kept them. You could have kept them as a minute or hour. It doesn't matter. Okay, is that okay? Now, how do I know then? But this is important. In order to calculate the distance, which one do we need to use? The minute or the hour? Hour, right? Because rate is given to you in terms of kilometers per hour. So how do I find the distance that he walked? Yes, sir. Yeah, rate times time. Right, Carly? How do I find the distance then? Tell me. Okay, Carly, do you understand that the time it took him to walk was 1 over 5 hours? Is that okay? Yeah. Okay, if I know that the time it took him to walk is 1 over 5 hours, to find the distance, all you have to do is use the formula that says what? How do you find the distance? All you have to know is what? Rate and, don't you have to know rate and time? What's rate times time? What does that give you? Distance. So what's our rate for walking? 8. Correct? Carly, look at your chart. Let's go back to our chart. Don't we know the rate for walking? Right? Rate for walking is 8. We just figure out the time, which was what? What's the time for t came out to be what? We just got this. Look at what if the t came out to be 12 minutes? 2. So it came out to be 1 over 30, right? So how do you find the distance then? Okay, I'll give you time, guys. I think people. Okay, good. Think about this. How do you get? Okay, Carly, do you understand that the distance for car travel is 48t? Would you agree? Yeah. What about the distance he walked? It's 8 times t plus 1/6. Would you agree? Yeah. We did all this work to find that t is equal to what? 1 over 30, right? 1/30th. So, remember, this is a round trip. In order to find the distance that car travel, all you have to do is what? You plug it in. 48 times 1 over 30 will give you the distance, wouldn't it? But that's the distance that car travel. How do you get? Because don't they walk? Aren't they asking how far did the mark walk? Right? Exactly. Now, how do you get 1.6? You do 8 times 1 over 30 plus 1/6, right? But guess what, class? If I do that, does it matter which one I plug into?
No.
Why not? If I do 48 times 1/30th, I still get 1.6. If I do 8 times 1 over 30th plus 1/6, I still get 1.6. Why does it not matter? This one's kind of interesting. But you guys are correct. It is 1/6. Why does it not matter? Sammy? Yeah, because it's the same distance. So it wouldn't have mattered which one you plug into as long as you did it correctly. Right? By the way, guys, may I ask you this? Can I plug in 2 minutes instead of 1 over 30th?
No.
No. 10, that will be 2 hours. Okay, that'll be wrong. So at the end, did you guys write down the sentence like this? Mark walked 1.6 kilometers in either 12 minutes or 1/5 of an hour, right? Because it's 10 minutes plus 2 minutes. Or 1 over 6 plus 1 over 30th, right? That's 1/5 of an hour. Any question on this? Okay, Carly, does that make sense now? Yeah. All right. Oh, and then some of you mentioned you guys wanted to see number 3 again? Because we kind of didn't have time at the end. So let's look at 3 again, okay? Yeah. So let's review quickly what we were doing on number 3, right? You guys remember you had Carla and Dean Kala is going to, well, let's read it. Can somebody read this for us? Thank you, Matthew.
Carlo currently goes in south 20 kilometers per hour.
Mm-hmm.
Dean is able to pull Dean from the same point 15 minutes later catch up to her.
Mm-hmm.
Dean bikes at 34 kilometers per hour. How long will Dean catch up to her?
Yeah, this is, remember, thank you. This is, remember, this is a same distance. Dean is trying to catch up with Kala, right? So Dean leaves 15 minutes later. So who's going to be actually traveling longer, and who's going to be traveling shorter? If Dean leaves 15 minutes later, who's going to be on the road longer? And who's going to be on the road shorter? Dean. And by 15 minutes, right? Could we use 15?
Yes, 1/4.
You have to use 1/4. Do you see why for Kala it is, if I let T be the time it takes Dean to catch up with her, do you see how the time for Kala is going to be T plus 1/4, because Kala will be 15 minutes
Late.
more.
Yeah.
Should be on the road more than Dean, correct? Because Dean leaves 15 minutes later. You guys remember that? And what do we say about the distance? If Dean is trying to catch up with her and they're leaving from the same place, the distance for both of these are the same. You guys remember? Right? Wasn't this the equation? And remember I asked you to solve? So of course, how do you solve? You distribute 20. But the important part here is, do you see how the time for Kala is longer than Dean's time? Right? That logically makes sense, doesn't it? Because Dean leaves 15 minutes later. Right? Do you guys understand? So the time for the Dean to travel is a lot shorter than time for Kala to travel. But how is it possible that Dean to catch up with Kala? Yes.
He goes at a rate faster.
He goes faster than Kala. 24, right? This is 24 kilometers. Kala is 20. So do you guys remember this? So multiply both sides by 20. Distribute 20. You get 20t plus 5 equals to 24t. Correct? And how do you get t by itself? Subtract 20t from both sides. T comes out to be 1/4, which is 1 hour and 15 minutes. And there you go. Isn't that what they're asking? It will take 1 hour and 15 minutes for Dean to catch up. Now, then how long was Kala been on the road for? If it took Dean 1 hour and 15 minutes, how long was Kala on the road for? Yes, sir.
1 hour and 30 minutes.
1 hour and 30 minutes, because 15 minutes more than how long Dean was been. Does that answer your question then? Some of you wanted to see this again. Does that make sense? Any question? Are we good? Okay.